All right. Hey, everyone. Thank you so much for joining us once again. This is our Core Devs call, the 16th call. And I think we have a very interesting agenda. So I'm going to start by, hey, Yaniv, welcome. I'm going to start by sharing my screen really quickly. Let me see if you're seeing it. Yep, that should be it. It's not full screen, but anyway, you can see it, right? Thumbs up, Alex, someone? Thumbs up.
Yes.
Perfect. Thank you, Matthew. Okay. All right. So let's get started. As you know, these are monthly calls. You know, we always upload all of these to YouTube. So I'm going to be sharing in the chat and in the show notes a link to our YouTube channel where you can check previous recordings if you haven't attended those in the past. And there's a public website there that's the Core Devs workspace. We have it. It's a Notion page. You can check all of these during going to the graph.foundation. You can subscribe to our ecosystem calendar and be in the loop about future workshops and other Core Devs talks we'll be having, and also get access to the Core Devs workspace. That is where we have the multiple working groups. You can monitor the different work streams that are active, get access to meeting notes, recordings, all of that good stuff. So I invite you to follow this link and be part of our community. Let's get started with just a very quick update on the MIPs program. As you know, this has been announced a couple of weeks ago. I did cover it in the previous Core Devs call. I don't want to get into much detail today because we've already kind of covered what it is. In a nutshell, it's the program that the foundation structured, and we've kickstarted it 1 week ago, where we'll have multiple chains on this testnet. And just making sure that we can, in due time, once you have the proper quality of service, migrate those chains to the network. And so that means that we're ramping up with new indexers that are helping us getting started and create some supply for those chains. And so if you've been around, it's similar to the mission control, the first incentivized testnet we've launched 2 years ago. And so this is a great opportunity for indexers to get started and join us and serve new chains like Gnosis chain. That was the first one announced and it's already live. We started the phase 0. The program has started, as I said. The agreement has been sent. Please do sign it if you're participating. We're very happy to have all of you joining us and helping us out. And it's a major milestone for the protocol, because as you know, we're all about decentralization, and the only way we can get there is to have more indexers joining our network and serve multiple chains. So it's all going well. Thank you for joining us. I will be sharing also the page to the link to our brand new MIPS homepage we have in Notion, where you can follow up with the different phases and missions that our participants are going through, and you can also check upcoming workshops you should be aware of, so that you can properly ramp up with the protocol and know how to run your index node. So that's it. Let's go through the agenda quickly. So today we have Adam as a node, as always, kind of. Thanks, Adam. Adam is gonna walk us through file data sources. We've been also talking about it. There's some updates here, and we can understand a little bit better what this is and how developers can get their hands on it. And this is one of the ways we are, one of the things we are working on, just to make sure that we can better serve the NFT community and sort of use cases. So that's fairly exciting. And then we have Subgraph's data pruning as well. Adam, thank you. This is fairly important for Subgraph developers. Obviously, we'll get to know more. Then, as you know, one major update we're bringing to the protocol and the network is the migration to L2, specifically Arbitrum. This has been covered in the past. We've covered GIP-34 and I believe 31 before. And so today it's all about GIP-37. That's in the forum. I'll post a link to it as well. And Pablo from Edge Node will be talking about this as well. Then we'll have our going through curation V1 and what it means to, what are we thinking about when we're thinking of overhauling curation and the recent efforts on improving the overall developer experience, the whole user experience, making it super seamless. That's a big topic right now. And so Howard will go through some of these initial details, and in the future core devs call in a month from now, we'll go even deeper here. So do subscribe or do follow our updates. It's fairly important. And then we're going to wrap up with the kind of a brainstorm on bringing substreams to the network. That's something that's fairly new. We just started having this conversation as part of the Data and APIs working group. And so we can take the time today to continue this discussion. And I think it's a nice way to finish today's call. And that's going to be led mostly by Adam, Alex, and Streaming Fast, but obviously all other core devs can and should participate, but specifically the folks from the Indexed Experience working groups and other indexers we have joining us. So yeah, that's it. Let me pause here. I'll stop sharing my screen. And Adam, are you around and ready?
Yeah, sure. I can go on. Let me share my screen on this. So, well, I guess I'll give a bit of context first. So file data sources is quite a sort of general sounding name. That's intentional. So the functionality is focused initially, as we'll talk about, on IPFS. But the model here is to really think about taking graph node, which is obviously really great at thinking about on-chain events and has initial support for off-chain data in the form of fetching IPFS files during mappings. We want to think about, okay, how can we support more types of off-chain data sources? How can we make that existing implementation more robust? And how can we also move forwards on the path to determinism? So obviously, folks may not know, but obviously determinism and deterministic indexing is a requirement for subgraphs on the network to end indexing rewards, and also to have sort of attestable slashable queries, because it's only when indexing is deterministic that you can actually compare a result from indexer A and indexer B and come to a sort of definitive answer when it comes to sort of arbitration or any sort of other sort of the sort of slightly more robust mechanisms that the protocol is also moving towards. So the current status of file data sources or IPFS data sources is that they are not deterministic, because essentially you may not be able to get a file back from IPFS. Anyone who has used IPFS in production has probably encountered some headaches when it comes to finding data on the network. And so this initial release isn't getting us all the way there, but it's essentially doing a lot of great groundwork to take us or allow us to move in that direction. I don't know, I think I saw Leo was on earlier, but I guess big shout out to Leo, who's been spearheading a lot of this work, Theo from Edge, who's also been working on this, and of course Zach. Zach's also been very involved in some of the thinking on how we move to determinism in the future. And so, yeah, so without further, I suppose, ado, I just want to, I guess, give folks a sense of the change that we're currently working on, where we're currently at in the rollout of that. So if you take, oh, that's a good start. If you take a blockchain, so Subgraphs obviously listen to on-chain events, and then we see an event that we care about. This is the existing IPFS implementation. In an event handler, you're able to reach out and you've got an inline IPFS cat. So essentially that will be reaching out to try and find a given file from IPFS. It'll fetch it, then it might succeed. The file might be returned. You can then sort of process the data in that file. Or it might be that for whatever reason your IPFS node isn't able to find that file. It might not be available, it might not appear in time, but essentially you can have a success or failure. This then leads sort of naturally to determinism, because if one indexer is successful, one fails, then the resulting write to the store will provide different data. You'll have different results. And also means in the case of failure that if there was really useful, like important information in that file that was going to be useful or important to users when they came to query the store and query the subgraph, essentially it's like one and done. It's a single attempt to fetch the data, one single processing of it. And so if you don't find it at that moment, then you're sort of stuck. Areas where this sort of means that subgraphs aren't usable is an example if you've got an art platform where essentially the file is uploaded to IPFS around the same time that the on-chain transaction happens, then it can be that essentially the transaction happens before the file is then found, and then essentially you've got a subgraph that doesn't have a pointer to the actual important metadata about with information about the art. So it has problems in that you've got this sort of blended success failure non-determinism. You've also got this one done like lack of robustness. So it's missing on a couple of counts. The initial implementation is essentially to take this pattern which has this inline IPFS cat and essentially instead of having that inline event, have an inline event which is the creation of what we call a file data source. Where with IPFS is the first implementation of that, where essentially when you see a hash on chain that you're interested in, you'll create a data source, which basically is then an asynchronous thing, which will try and find that file. If it finds it, it'll then process it. It will retry over time until it finds it. So that gives you some robustness. It means that if you don't find it the first time, maybe because of that kind of race condition, you've got another chance, so you can provide that useful API to people. But then crucially, because it's a different data source, you've got these sort of two separate writes. You can start to move to deterministic indexing, which is to say that you know which data has come from the chain, you know which data has come from the file, and then won't get into the details, but if you can move towards consensus on file availability across indexes, then essentially everyone can essentially update their database in the same way, treat the same files as available or unavailable, and then you have determinism, and you can have indexing rewards and all of the verifiable goodness that comes from that. So this is currently, in terms of where it's at, we're in testing of this. So there are a few nuanced things around like finding files in directories, which Felipe has been working on, just to make sure that we match the same sort of, I guess, functionality that we have here, but just with more robustness. So in the scope of testing that and working with specific projects to essentially make sure that we're meeting their needs, with the goal here really being, let's make sure we make something that's useful. And so then we can make sure, because making things deterministic is hard, that it's going to be worth, essentially worth the squeeze. So that's like an overview of, I guess, the architectural change that we're making here. As I said, this improves things in terms of robustness, race conditions, handling timeouts, temporary unavailability. It's extendable, so yes, I'm moving to supporting directories. You could have file data sources which are indexing Arweave, which are indexing ceramic, and then maybe even in future, these non-deterministic or variable things like IPNS or even HTTP endpoints could be file data sources, which could then be treated in a certain way. So that's obviously a huge going to be a hugely important development as we move towards supporting NFT use cases, which obviously can be found in Arweave and often on HTTP endpoints for all sorts of various reasons. So that's obviously an important part of this feature. There's a path to determinism. You've got the there's obviously some work to do there in terms of getting file availability consensus and doing the work to actually remove or add data sources. It introduces some constraints. There's limited store access in the file handlers, and they need to be separate entities various ways. But thankfully, some of the other features that we've been working on, or the Guild in particular, have been working on nested filters and those kind of things, which actually mean that having separate entities or like child entities of primary entities isn't so much of a problem, because you can filter and you can sort by those by the features of those entities. So I'll pause there. As I said, it's been great work from a bunch of people across the team. And yeah, any questions would be welcome.
If anyone else wants to ask a question, they can just raise their hand. There's a reactions button in Zoom you can use, and I'll allow you to speak. All others, like the different co-hosts we have, can speak right away. I think I see one. Oh, there you go. Obviously, of course. Simon, go ahead. I'll make you co-host actually.
Well, can I, because I cannot start my video anymore, but it's okay.
You can now. You can now.
Right. Hello.
There you go.
Yeah, you quickly touched the subject, but what's the thinking about getting consensus amongst the indexers if a file is available or not?
Yeah, so I think there's been a bunch of designs on this over the years, and I welcome, I guess, other folks to jump in this. I think there's been discussion of an availability chain, essentially a chain dedicated to identifying whether files are available or not, which obviously you then get into the interesting things around like who validates that chain, how do you avoid things like spam, and how do you make sure that it's kept up to date and those kind of things. But if you have a chain which says which files are and aren't available, that kind of addresses the problem. I think it does introduce some challenges if you want real data freshness and those kind of things. I think there is a really interesting space for indexers kind of being on the hook to like help other indexers find files potentially, where if you've essentially attested to results including a given file, another indexer can't find it on IPFS for whatever reason, like having some kind of means of encouraging indexes to share data with one another, because one big problem obviously with NFTs is the problem of files just disappearing from IPFS. Then the NFT is not there at all. There aren't that many actual incentive or mechanisms for keeping files around. I think there is a really interesting design space there. And then like I guess the mechanism which hasn't been explored or like thoroughly looked into so much as because it wasn't sort of around, I guess, the gossip network as a means of at least coordinating on what files are and aren't available and who has different ones. And I think that that's quite an interesting thing, which I haven't thought deeply about, but I think could be pretty interesting.
Thanks.
Perfect. Adam, do you want to move on?
Sure. Yeah, we'll
perfect.
Move seamlessly, I guess, on to talk about pruning. So this is another functionality which is kind of in the same spot. So I'll give the same context again. This has been great work by David from Edge, who's been working on pruning subgraphs. So essentially, folks again may or may not know, a subgraph is kind of archival by default, which is to say that it keeps a history of all of its state. So from the first block when it started indexing to the most recent block, you can essentially query that subgraph for information at any of those blocks, which gives you really rich access to historical data. It's crucial for arbitration on the network, because you'll need to be able to go back and query and check for essentially this, like the subgraph state at the same block between different indexes if you want to dig into, say, if there are discrepancies or things that happen. So and also it's important if there's a reorg in the chain, you'll need to be able to go back some amount of time. But I think it's also the case that a lot of subgraphs are keeping a lot of history that actually is never queried. And David ran some analysis to see when most queries are relative to the chain head, and actually obviously a huge majority of people are just querying for the data at the chain head rather than for historical data. And so why is this relevant? Why is this important? Essentially it means that it can slow down indexing, but also particularly querying if you've got subgraphs which have got lots and lots of essentially archival or historical subgraph state. And I think Masari actually have been a real, as a subgraph power user, building huge subgraphs with lots and lots of analytical history. Some of their queries can be very slow, essentially, because they've got so much historical data. And so pruning is a feature that's been aiming to, in a specific case, like essentially let people remove some segment of history. Not all, for the reasons I said around arbitration or around handling reorgs. But some. So I actually point to the PR here, which I think is quite descriptive. But essentially, Graphman prunes. This is an indexer control at the moment, but essentially an indexer can choose to prune a given subgraph or other deployment, and essentially remove state from a certain number of blocks, default 10,000 before the current subgraph head. And after pruning, the deployment can only be queried at block numbers at least as high as that block. So when you query, you get a bunch of information back. So again, this is kind of interesting to see in like for a given subgraph, the number of sort of historical versions. So like Uniswap as one example has day data is nearly 1,300 days. Actually, you've nearly got 1.4 million versions. So you've got a lot of, you've got like the ratio here gives you a sense of how many actual, like how much actual recent current state you've got versus historical state. But essentially this prunes it out. This pruning took 553 seconds. I tested a database of sort of 60 subgraphs, shrank by about a third, with some subgraphs being reduced by 90%. So this is functionality that isn't necessarily applicable to all subgraphs, but can like make material differences in terms of storage size, but then more importantly, query speed for developers. So in terms of where this is at, like as I said, it gives you faster queries, it gives you smaller data sets. There are some drawbacks in that you get limited time travel queries. You also lose the ability to graft before the point where you pruned. But I guess we're like, it's going to be pretty important in terms of speeding up queries. And yeah, essentially it's at the point now where David's been testing with Vincent from Asari on yeah, seeing what the impact is. In terms of like, then depending on that impact, there's some sort of developments here. One is a split history approach, which would kind of give you the benefits of pruning without actually throwing away all that historical state. So there's a question as to whether that's going to be a good approach. Then there's also this question of what should be configured by the developer versus the indexer. So sometimes developers might want to say, look, actually, I don't care about historical state. You can throw it away. I'll always query for most recent state. And developers will want that level of control. At the moment, as I said, it's just an indexer control. So it's more, if indexers are seeing that lots of queries are slow, they're only getting recent queries, they could say, okay, actually, I'm going to get rid of a bunch of history. I'm going to increase my query speed, reduce my database size. And then, yeah, I think over time we may add developer controls, I guess, within the manifest, but that's not currently the case. But we're testing, and we'll see what we learn when we see the impact on some of these large production subgraphs. And so that's pruning. Any questions about pruning?
Adam, this is Matthew. Question: how does this impact proof of indexing if all the indexers prune different amounts of the tree, and the query comes from the gateway? Then how does it know to route it to a node that has the appropriate amount of history?
Yes, so we've talked to Theo about this. I can't remember if they're so there've been some updates to the indexing status API, which I think do essentially reflect the changes when you prune to like the start block that the subgraph can be queried for. I'll need to check, and so this isn't yet live on the network, but I'll need to check with Gateway team, because they're like, I think there was maybe a change that they'd need to essentially account for that. So it would then know that certain indexes, in the same way that it checks for where they are at the chain head. I think the other side of the question around proof of indexing is unchanged by this. It's generated at sort of indexing time as you process blocks. So it's not dependent on, because essentially it's like a digest block by block. It doesn't matter what's in the database at a given moment, like the proof of indexing themselves, they won't be purged from the blocks from history. It will just be the state. So you would be, if you wanted to rewind, actually that was another thing that you can't do. You can rewind beyond where you started pruning and re-index and see if there were some changes or whatever. But yeah, proof of indexing should be unaffected. Jim.
The gateway does not yet support these queries, well, queries for prune state. So if you prune and someone makes a query, you might end up being penalized because we'll think that your indexer is down. But I think we can prioritize that change. I didn't know that this was going to be announced yet.
So it's, yes, as I said, it's not, this isn't part of a release.
Oh, okay.
This will be in the next release. So not the one which is currently in, not 28, which is in release candidate, but it'll be the one after that. As I said, we want to test it first.
Okay, the gateway can be ready by then.
Thanks, Zach. Sorry for if that was a bit of a side swipe.
No problem. No problem.
Jim.
I think that's basically the conversation has answered my question, but my question was going to be sort of there's this, you would need to have synced the entire, let's say it's a big complex subgraph, not Unisub, whatever. You would need to have synced the whole thing anyway to get your POIs prior to deciding to prune, right? So, the whole POI doctrine stays in place. The other thing I just wanted to comment, I think this is awesome. The idea that immediately comes to mind for me, just thinking from an indexer's point of view, is it opens up possibly a different class of indexer, like a super lean type of operation, where you're offering, you're getting yourself very close to like New York data centers or whatever, wherever you need to be ultra low latency, but you're also super low footprint, right? Because a lot of indexers cost, it's all about, it's not so much about compute, it's about storage. Storage costs, I mean, it's off the charts how much we have to pay for storage. So the idea that you could potentially run, an indexer that's very lean but very low latency, is very appealing. I think it's a very interesting thing to sort of think more about.
Yeah, I think it'll be interesting to see different indexes sort of, and I think there'll be more and more of this as the range of potential infrastructure. Like we haven't gotten or talked yet about like when indexes could be running fire hoses or substreams, or maybe touch on that at the end, but it'll get from being like everyone's running the same thing to maybe indexes making slightly more strategic choices about what kind of indexer they would like to be, which I think will be really interesting.
Great. Yeah, we probably will cover that at the end. So we have to continue, being a bit of a timekeeper here. Thanks for the questions. Thanks, Jim, as always. Moving on, Pablo, you're ready? And we'll probably now leave questions till the end, so we're making sure that we can cover everything.
Hello. Thanks, Pedro. Okay, I think I'm ready. I'm gonna share my screen. Sorry about that. I'm gonna share my screen now. If I can find the right window.
Yeah, you have the rights to, so you should be able to.
Yeah, sorry. It apparently, since this is a new laptop, I'm gonna have to rejoin in a minute. Just 1 second. Sorry about that.
If you want, as an alternative, it's fine. In the meantime, I'm going to share a link to GIP-0037. Yep. I don't have these slides, otherwise I will share it myself. So let's wait some couple of seconds. Okay, he's in the waiting room. I'm making co-hosts. Pablo. There you go. Pablo, your co-host again. Want to try it? All right. If you can't, feel free to send me the link and I'll share it myself. There you go.
There we go. All right. My apologies for that.
It's actually a black screen.
Yes, because I'm on the wrong window there.
There. Yeah. Yep, we can see it.
Cool. Sorry for that delay. I'm going to give a few updates on the progress we've made on the L2 scaling efforts. This is again from the smart contracts perspective, because that's the team I'm working on. So I'm going to focus mostly on that. My last update was in June. So if I won't go into many of the details that I already presented there. You can watch the recording for the June Board's call, but I'll still do a brief recap. So first, what's the plan for the L2 scaling, the moving the protocol to Arbitrum? There's 3 stages. So right now we're before starting stage 1. The first thing that we want to do is we want to deploy a bridge so that users can move the graph token from mainnet Ethereum to Arbitrum. And that's the thing we're working on right now. The code for the bridge is pretty much ready. It's been audited. We still want to be very confident on this code, so that there's some few last steps before we actually deploy that to to mainnet. And I'm gonna expand on that in a few minutes. The stage 2 is once we have a protocol running on L2 and we can move tokens between L1 and L2, we need to figure out how we distribute indexer rewards on L2. Because right now the token is minted on L1, and then we have to figure out, like, do we mint tokens in L2? Do we send tokens from L1 to L2? How do we sort that token issuance problem once we move to Arbitrum? And then finally, stage 3 is we have a protocol working, we can actually distribute rewards in L1 and L2. We want to make it easier for people to migrate subgraphs, indexer states, delegation, etc., from L1 to L2. So we want to work on some helper functions and some UI so that it's easier for people who have a subgraph on L1, for instance, to just run a transaction or maybe a couple of transactions to get that subgraph moved to L2 with its curation signal and so on. So that's going to be kind of a later stage. Right now, our main focus is stage 1 and stage 2. That is, we want to get that bridge deployed to mainnet as soon as possible, and then we want to get the rewards problem solved so that we can enable indexer rewards in L2 as soon as possible as well. So just a recap of what stage 1 looks like is we have a bridge. That bridge is a couple of contracts on L1 and L2, and it uses the Arbitrum Ethereum bridge that is something provided by Arbitrum. So when people want to move tokens from L1 to L2, they put them in a bridge escrow by calling the L1 Graph Token Gateway, and that triggers minting those tokens in L2. And then when people want to move tokens from L2 to L1, they send those tokens to the token gateway, which will burn them, and this will trigger a transaction in L1. I mean, someone needs to trigger it after the dispute period is over, 7 days later, so that those tokens can then be sent from the escrow back to the user's address in L1, which could also be a contract. So updates on this particular part of this particular stage, GIP-31. We have the bridge implementation. It was audited. There were no surprises during the audit. A couple issues that were solved after the audit. So we have like a pretty robust implementation, and we've tested it on testnet. We've tested it on Gurley and Arbitrum Gurley. So we know that this bridge works, that you can send tokens back and forth. There's some recent updates. That is, this week we figured out we can make the call hooks interface safer. And for those that haven't seen this or don't remember, part of the benefits of this bridge is we can send tokens with data atomically. So for some of the migration helpers and some other things that require communication between L1 and L2, we sometimes want to send some tokens and then send some call data together with the tokens so that some behavior is triggered in L2 when those tokens arrive. And that used to be just, we have a wide list of who can send call hooks like this. And that used to simply be call the destination address with whatever call data was passed by the sender. So we're just making that safer by making that a fixed function interface. So whenever someone sends a call hook, it will always call a function called on-token transfer with some specific parameters. So that's going to make it safer from re-entrancy risks, or just the idea that, like, if you end up calling an untrusted contract, there's at least some structure behind it, and you can't just do whatever you want. So I'm going to push an update for GIP-31 very, very soon. I'm actually working on writing that today. And then other than that, other teams are already working on all of the off-chain components, like the Graph Studio UI, Indexer Agent. There's a bunch of other things that go around deploying the bridge and deploying the L2 network. And yeah, I can't go into detail on those things, but just know that it's being worked on. And then that's for the actual code for the bridge contracts. As I mentioned, the audit was completed, but we want to get even more confidence on this code. So we're working on setting up a code arena contest. And for those who aren't familiar, this is a sort of decentralized audit where certified wardens, anyone can become a certified warden, and you can participate in auditing the code for a bounty. So keep an eye out for that. That's still not set up completely, but we're working on that. So if you're a warden or if you want to be a warden, yeah, this might be a good opportunity to get involved with looking at this code and helping to make it secure. So moving on to stage 2. So once we have this code arena contest finished and we can get the council to approve the transactions, we'll be able to actually deploy this bridge and the L2 network without indexer rewards. And for stage 2, we want to enable these rewards. Previously, we had presented GIP-34, and this is just a brief recap of the main idea behind that. That is, we want to be able to send all of the tokens for indexer rewards from L1 to L2 so that there is no minting in L2. And this requires adding a reservoir in L1 and a reservoir in L2, and then the rewards would be distributed from this reservoir instead of minted whenever an allocation is closed. And we have the implementation for that. It's been audited as well. There is a system for a keeper reward that incentivizes people, calling this drip function that generates all of the rewards for the upcoming week. And we think this would work. The problem is it ended up being quite complex. It's a lot of lines of code. This system for sending messages between L1 and L2, it works. It's, I mean, supported by Arbitrum and everything, but doing that in a permissionless way or in a decentralized way where anyone can call that function is kind of difficult. It's difficult to ensure that this works correctly and that there's no griefing going on and things like that. So yeah, it's a tricky setup. And while we still think this could work, it made us think, can we have other alternatives? And then we had Ariel's idea of what happens if we make indexer rewards linear instead of the current compound interest formula, and then we just mint them in L2. So we ended up actually implementing this, and this is GIP-37 that is now competing with GIP-34. So for this stage 2, we can have option A, that is mint everything in L1 and send part of it to L2, or GIP-37, that is mint the L2 rewards directly in L2, mint the L1 rewards directly in L1, and then just make it so that it's easier to know how much of the tokens have been minted in L2, so that if someone wants to bridge those new minted tokens from L2 to L1, the bridge is still able to mint them, but it has a clear boundary of how many tokens it can mint, because you can't ever have more than X amount of tokens that have been minted in L2. So if you want to look into this in detail, there's the forum link here. So there's a forum thread with GIP-37. I really encourage people to take a look at it, provide feedback if you can find any potential issues with that, or if you can provide an opinion on whether GIP-34 or 37 is a better path forward for the graph. Because yeah, both of these could work. Lately, we've been leaning towards GIP-37 because it's really a lot less code, it's a lot cleaner, it looks a lot simpler, and we really think it makes the system more robust because we've removed that L1 to L2 communication completely, at least for indexer rewards. So the way rewards would be issued and distributed is simply replicating whatever we have now in L1, that is, you close an allocation and the rewards manager mints some new tokens. We have the same thing in L2 right now. The only difference is the bridge would have to be modified because now when we send tokens from L2 to L1, there is a small chance, because it's only if the escrow doesn't have enough funds, then we might have to mint a few tokens to send them to the destination. But this minting is actually limited because we know, because it's a linear issuance, it's very easy to know how many tokens could have been minted in L2 and just limit the minting to that amount. So that kind of reduces the potential impact of if someone found a critical vulnerability with the native Arbitrum Ethereum bridge and were able to even send a fake message to the bridge, there's still a cap to how much damage something like that could cause. And a nice consequence of this is when we move to the linear rewards, all of the rewards per signal calculation, this is part of like something that we have implemented in that rewards manager contract. It simplifies from this exponential formula to the linear formula, and it makes everything a lot easier to handle in the code. So yeah, I think, yeah, that's what I have. And maybe if we're going to have questions at the end, if anyone has questions, but yeah, the main thing is if you folks want to look at these GIPs and comment and get involved, that would be great. So yeah, thank you.
Thanks, Pablo. Yeah, indeed, we should try to move the Q&A to the end. We're behind schedule. Thank you so much. I know Jim would probably want to say, please do go to the forum and do comment on this and give your feedback. That's important. Yeah, Yadiv's comment, given the number of bridge acts, a simple approach with smaller attack surface areas seems prudent. I would have to agree. Yep. Okay, thank you so much. Howard, how are you? Oh, I have some messages from Howard.
Oh yeah.
Yeah.
Here. Can you see my screen? Oh, doesn't look like it's sharing.
Not right now.
How about now? Can you see it now?
Not on my end. Not yet.
I'll try again.
If it's the overleaf document, oh, there you go. Still.
Is it showing now?
Zoom. You're sharing Zoom. There you go. Yep.
Okay. And you can hear me fine?
Yep.
Loud and clear.
Okay, cool. Then I will jump on in. So this morning I'm giving a little bit of an update on the curation side of the protocol. And really what we're trying to do here is give an update to what's currently being used. And so we're going to call this Curation 1.x. It's not a full-scale, redesign like, say Curation v2 or more long-term solution. But what we want to do is really want to patch some of the bad aspects or things that we are seeing in the curation market today and help pave the way for, future developments to help the developer experience and everything, especially once we're on L2. And so, building on a lot of what, Pablo was saying with L2, we're actually trying to help make a very simple patch that we can deploy specifically on L2. So everything that I'm talking about right now is going to be strictly on Arbitrum. It's not going to apply to subgraphs on L1 Ethereum. And so just to overview a little bit, when we're thinking about today with curation, we have these things called bonding curves. I'll give a specific example, with an illustration on the next slide, but I want to highlight some of the concepts here that have come up with various interviews with curators and others. And one of the biggest things we see now is the complaints about things like rug pulling, because you might provide some level of signal on a subgraph and come the next day you might show up and look and you say, wait, there's only, let's say 3,000 GRT of signal and I put in 5,000. Why am I suddenly exposed to all of this? All I want is my subgraph to get indexed. And so that can be quite difficult and frustrating for curators today. And it would be one thing, I think, if it wasn't an unknown downside, like if you were to say, hey, I'm paying a 1% curation tax, like that could be upfront and transparent. But as it is right now, there's a lot of things happening where curators are effectively taking signal from each other in a sort of zero-sum game. And that's not actually helping necessarily incentivize curators to focus on actually finding valuable subgraphs. Now, when I say valuable, I mean this in a sort of general sense. I'm not saying just the ones that get the most query fees or the most frequent queries, because some dApps actually might be really dependent on a particular subgraph, but it might not have often or frequent queries, but it could be critical to infrastructure. And one way or another, we want curation to help us be able to find the valuable subgraphs. And today that can be difficult, in part because query fees aren't as significant. And so these sort of zero-sum rug pulling rewards are really large relative to the query fees coming in presently. And also right now, it can be really difficult for developers or curators just to reason about what is signal and how much do I need to put? Do I need to be adding more? Like it seems really complicated. And so what we really want to do is want to help improve the developer's user experience. And so this patch that we're providing today is a simple upgrade where we'll make it so that curators can't take signal from each other. And by that, I mean, if you, let's say, signaled 500 GRT and I put in 1,000 after you, that suddenly you'd be able to take, 200 of mine or something like that. We're going to try to make it so that it's more of a level playing field in that regard. Now, there are trade-offs that we're making here, but again, we're emphasizing that these are just a step in that direction of trying to improve the user experience. And we also want to help make sure that there is some sort of nice relationship between signal and the quality of service. We want that to be as predictable as possible as we're moving to L2. So really the proposal here is a simple modification. We're going to, in essence, just flatten the bonding curves and change what we presently have from being something with a slope to something that looks more like what we'd see as a pool, similar to something like delegation. And to recap what bonding curves look like is, as someone mints more and more shares, they're providing more signal on a subgraph. And the little area in any particular region of this is telling us, one, how many shares someone has and what price they're entitled to. So the shares from here to here have a larger area. And so someone that sells off when there's a lot of shares is able to make a lot more money than if they sold off over here where there's a small area. And so this naturally incentivizes curators to come in quickly so that they can get the lowest price they can and then sell off later when there's a high price. And this can actually cause problems for us when we're thinking about market design, because it actually disincentivizes curators from looking around and actually taking the time to do research and due diligence on these subgraphs. But if instead what we do is we just say, hey, everyone gets a portion of the pie in equal amount to their signal that they provide, then if you put in, let's say, 10% of the GRT or 15%, you'll get 10 or 15% of the query fees that come in as a reward. And so we're kind of shifting from what we see here on the left, where if someone adds signal, they're pretty much adding this little slot, to on the right, where if you add some, you're adding a piece of the pie. And so if you remove your piece of the pie, you're not going to be harming anybody else. And another reason that we're doing this is because it's essentially a no-code change. This is a very simple update in that here, this is saying, hey, we have a particular slope that might be changing by subgraph, whereas if we just make it a flat bonding curve, it's actually the equivalent of a pool. So now we can sort of eliminate the notions of bonding curves from our ideas, or from our ideas of curation. And so tentatively, what we're going to do is we're going to provide a proposal on the forum. This is essentially drafted. We plan to have this up this week, and we'd love to get any feedback on that, but it will, again, only apply to the subgraphs on L2. And this is really helping pave the way for future things like we've talked about previously in the forum or elsewhere about Curation v2. And we really there want to hopefully encourage a sort of like SaaS-like experience where we can simplify this for developers while also still communicating clearly to indexers, here's the valuable subgraphs, so they can both be mutually benefited from the part of the protocol as mechanism. And so as an example of where future directions might go is it could be a simple monthly payment rather than having a potentially large upfront deposit where someone needs 10,000 GRT for quality of service X and 5,000 for a different quality of service. And so this update today is just a step in that direction, and we encourage any feedback on the proposal we'll make on the forum later today. And at that point, I think I'm going to close and see if there's any questions.
It's very good, Howard. I just wanted to add that this is part of a larger discussion, and as mentioned in the beginning, we will also be covering in the next Core Devs call more about this, specifically on the work around billing and price predictability, and hopefully we can share that in the next following weeks. I don't see anyone raising their hands right now, and we are very, very short on time, so we may not be able to have at least a meaningful discussion around this last topic of having substreams powered subgraphs on the network. But I think, yeah, I'm not seeing any raised hands, so maybe we can kickstart that conversation. I see Alex. Okay, yeah, let's do it then. Adam, Alex, do you want to get started?
Yeah, my call is like, I would love to have on that subject. People want to discuss different things or have opinions or just the general inquiries, to have a conversation running a little bit instead of us just doing presentation style. But maybe Adam had a little things prepared there, but please bring some questions in.
Yeah, I think the context here was also, I guess, to provide a bit of an update on where things are at. So I think we spoke briefly on this last time. We talked about this sort of proof of concept, testing a sort of simple subgraph that uses a substream as a data source. And I'd say the current focus, we're working quite a lot on more advanced substream, I guess well-known AMM, and essentially just rebuilding a lot of that same logic, cross-checking it with the subgraph. And I think we're doing that sort of work, making sure that that works when that's piped into a subgraph, but also then looking to the next stages, which are around like checking scalability, checking determinism, these kind of things. So there's then like how we go from that and a hosted solution to bringing this onto the network. And I think as long as we feel confident in the determinism of the solution, then that should hopefully be pretty streamlined. But it'll be quite a big change for indexes, because then that'll suddenly mean index will need to be running fire hoses and substream endpoints. So there's quite a big, I guess, infrastructure change as we get to that point. I don't know if Anton, you have a question on this.
Yeah, sorry, chat is disabled. That's why I could not.
Oh.
Yes, I could not write a question there. I have a question about the curation proposal, and basically, now at the moment, the query fees are distributed at the moment when the indexer closes its allocations, and at this moment, rapid movement between different subgraphs is punishable because you will lose your shares. But with this new flattened concept, I guess curators may predict when indexers will close their allocations, approximately into the end of the 28th epoch, and rush into the subgraph where the curation fees would become available approximately in a few days, and then go away from that subgraph because the curation fees are not expected anymore. And basically they are not subject to any punishment because of running to another place where another subgraph where they can wait for new allocations to be closed and to get query fees. Do you get
that? Is correct. Yeah. So, I mean, maybe to add a comment on here, as Pablo kind of laid out, there's like these three stages that are being built for L2. And in the initial stage, there's actually not intended to be rewards. Like it's first getting the bridge, and then we add rewards and so on. And so in the initial stages before query fees, we plan to hopefully provide more, updates and so on, so that, a more long-term solution can be, brought to light and sort of, discussed with everyone more openly in the forums and everything. But you are completely right that this is a downside of, having a flat bonding curve, is that people can pretty much jump in right and just collect some query fees and then hop back out. But we are presently saying is that this is worth the trade-off given the move to L2 and the lack of query fee rewards, but also because it helps prevent these sort of run on the banks and these sort of zero-sum exploits of curators from each other. But I think this is a great point that you bring, and I think it should be well documented.
Thanks, Anton. Getting back to substreams last minute, we hardly introduced the topic. I don't think we'll have time.
There's always next time.
Alex, there's always a next time. There's no shortage of things to be working on, and there's so many different things active at the moment. Yeah, let's move that conversation to a later time. We're at the top of the hour, and folks may have other meetings, right? So okay, Cohen has one last question. We have one last minute. Let's try to answer Cohen's questions, and then we can all hop off. Thanks though, Alex and Adam for joining the call. We can continue in other venues for sure. And next month we can do an update here and continue the discussion, possibly with others.
Kuhn, were you heading on?
Cohen, you're up. You can. Yep.
Yeah, my question was about the subgraph pruning, how that works in combination with disputes. Say I prune to keep only the last 48 hours. And I get disputed on at some point, and by the time it gets processed, that data is already long gone from my database. So how would that kind of scenario work?
Yes, I think the scenario where documentation and guidance, I guess, is required. I think Zach, we talked about this on the length of pruning a couple of months ago. I think we haven't fully thought through the implication of that on the network. It would obviously be a bit of a constraint if we need to always have everyone keep things around for the potential lifetime of which an arbitration could be brought. So I think we'll need to think on that. Zach, unless you have anything on the tip of your tongue.
Zach is saying in the chat his internet is cutting in and out. I can't answer right now.
Yeah, but yeah, certainly one I think that we'll need to document before this becomes sort of part of the arsenal on the network.
Would it rather than document also not be a case of making sure that you cannot prune things that you might actually need to keep storing? That if we need 2 times 28 epochs, that you can actually not prune anything shorter than that to basically protect the indexer against themselves?
Yes, this is a Graphman. It's currently a Graphman command, so that's obviously sort of outside of the context of the network, but it's a reasonable point. I don't know if we'd want to think about changing the default settings. Obviously, the length of an epoch will also then start to vary by, like, if it's a polygon subgraph, then epochs are different lengths in terms of number of blocks. There's not like a perfect standard number that could always be applied, but it's a very good point. So we'll think about, I guess we can think about those automated controls as well as documentation, as you say, to help people.
Okay, as always, thanks, Cohen. We are over time, so we should wrap up here. Amazing. Next time we'll make sure that we have time to cover everything, or at least balance the Q&A and topics we want to cover. But it's always great to see people asking questions, and there's only so much we can share in a 1-hour call. In the meantime, regardless, there's always updates in the forum. Feel free to participate. Join us on Discord as well. All of these things can be found there. And yeah, again, let's wrap up. Thank you all. Thanks for all speakers. Thanks for everyone who joined. I'll see you in a month. Take care, y'all.